Welcome to this short tutorial on using the FFTrees Fast and Frugal Trees R package. This tutorial is described in more detail in FFTrees, an R package to create, visualize, and use fast and frugal decision trees, published by Phillips, Neth, Gaissmaier, and Woike. So the first step in using the package is to install and then load the FFTrees package. You can install the package using basic install.packages commands, which I've already done, and then load the library by running library FFTrees. When you run the library, you can see the current version of the package, in this case 1.2.0. You also see that you can run the command ffTrees.guide to open the main package guide. And you can also see my contact information to contact me with questions or bug reports. So the second step is to prepare the data. And by that I mean separating the data into a training set and a test set. So we're going to start with the heart disease data set. This comes with the package. So just to see what it looks like, let's run the head of the data set. Here you can see that there are many different cues, so age, sex, and different medical tests. And the criterion is diagnosis. So this is whether or not the patient has heart disease or not. A 0 means that they do not have heart disease, they're healthy, and a 1 means that they do have heart disease. And if we look at the dimensions of this data set, we see there's 303 rows and 14 columns. So what we're going to do is separate the original data set into a training and test data set. So we do that by running these commands. The set seed here is just to make sure that our random split is the same every time we run this, just for demonstration purposes. So now we have a heart.train dataset for training and a heart.test dataset for testing. The next step is to actually create the trees, and we're going to do that using the FFTrees function. And the main arguments of the function are a formula indicating the criterion, in this case diagnosis, as a function of some number of cues. Now, if you want to potentially allow for any of the cues to be used, then you can just use a period, as I'm doing here. And most of the time you should be doing this. You then specify the training data set in the data argument, and then you specify your test data set, which is optional, but I think it's good to use, as the data test argument. And we're going to assign the result to heart.fft. So I'll go ahead and run this. It takes about a second to run. And now it's finished. So the next step is to inspect and summarize the trees contained in the object. So first I'll just print the heart.fft. And here we see that this object contains 7 different trees. And across these trees, 4 of the original 13 cues are used. It then tells me what the performance of one of the trees, in this case tree number 4, which has the best training performance. So here we see that this tree uses 3 cues, tall, CP, and CA, and here are some performance statistics. So these are performance statistics for the training data and for the test data. After printing the object, you can run a summary of the object to get even more information. So when I run this, 2 different data frames are printed, corresponding to the training and test data set. So I'll scroll up, here's for the training data set. Each row in this data frame contains information about a different tree. As you can see, there's 7 trees. And we can see the cues in the tree, the number of nodes, which is just the number of cues in the tree, the classes of each of the cues. C indicates character and is numeric. The exit structure, where 0 means a negative exit, 1 means a positive exit. The thresholds for the cues. The directions at which a positive direction is indicated. And then different performance statistics from the total number of cases, the number of hits, misses, false alarms, correct rejections, the sensitivity, specificity, false alarm rate, accuracy, balanced accuracy, D prime, frugality, and MCPC. So we saw before that tree number 4 was selected, and now we can see why. So if you look at the balanced accuracy across these trees, we see that the one with the best balanced accuracy has about 80% balanced accuracy. Well, that's tree number 4. So that's why it is selected tree number 4, because that is the highest balanced accuracy for the training data. And if we scroll down, we can see similar results for the test data. Now, the columns of the tree number up through directions will be identical between these two data frames because these are just the definitions of the trees. The trees are the same for the training and test data. The only difference is the performance. So these are the performance statistics for the test data. The next step is to actually visualize one of the trees and its performance results. And we can do that by using the plot command. I'll just expand this. So to use it, you just plot the object, and then you have some optional arguments. For example, main is the title of the data set, data is whether you want to plot test data or training data, and then an optional vector of decision names. And we'll see how these elements come into play when we look at the plot. So by default, it will select again the tree with the highest balance accuracy training performance, and here's our tree. On the top row here, we see again the title of the data set, the number of cases. And again, this was for the test data set, so there were 153 test cases. Here's the number of true diseased, true healthy, and the percentage of diseased and the percentage of healthy. And then here's the final tree. So here we see that the first Q in the tree is tall, and the tree works by saying, is tall equal to either RD or FD? If so, then immediately decide diseased. And we see that there were 18 cases that were false alarms in this case, so the tree decided disease, but in fact they were not diseased, and there were 54 hits. Moving down the tree, for any cases not classified as diseased after the first level, we move down to CP, and now it looks to see, well, is the CP value equal to either AA, NP, or TA? And of all these cases, it decides healthy. And here we see that there are 46 correct rejections and 5 misses. And now we move down to the final level, CA. If CA is less than or equal to 0, the tree predicts healthy. And we see that there were 15 correct rejections, 4 misses. And if CA is greater than 0, then the tree decides diseased. And here we see that there was 1 false alarm and 10 hits for this case. The final row shows you performance statistics summed across all decisions made by the tree. So these statistics are specific to levels in the tree, and this is all the statistics here are across all levels. So on the bottom left here, we can see a 2x2 confusion table showing the sums of the different classification results. So for example, this 64 hits here, well, that's just the 54 hits from the first level plus the 10 hits from the last level. And similarly for the other cells. Here we can see levels showing different performance statistics of the tree. So we see the frugality, which is the percent of information that was ignored by the tree, in this case 88%. We also see the average number of Qs used by the tree, which in this case was 1.73. So on average, cases were classified after looking at 1.73 Qs, which would be somewhere between tall and CP. Sensitivity, specificity, accuracy, balanced accuracy, and area under the curve. And the area under the curve can be calculated from this curve from plotting the ROC space on different trees. So these numbered values in green, 1, 2, 3, 4, 5, 6, 7, are the 7 different trees in the FFTrees object. And here we see that 4 is highlighted, indicating this is the tree that's being displayed here. In addition to the performance of the fast and frugal trees, we also see the performance of different competitors. So CART, logistic regression, random forest, and support vector machines. So here we can see in this case that tree number 4 has a higher sensitivity or hit rate than the other algorithms, but it has a bit lower specificity. If we wanted to plot a different tree, we can do that by including the tree argument. So for example, if I write plot part.fft, and now I say I want to look at tree number, let's say I want to see tree number 1. And I just say tree equals 1. This will be actually the training data in this case, because I didn't specify the data. But here we see that now tree number 1 is highlighted, and here's how this tree looks. And you can see now why this tree has such a low sensitivity, because the only way it's going to decide signal is if all 4 of these Qs all go in the same direction. So to be classified as signal, tall has to not be satisfied by here, CP is not satisfied here by here, and so on. And the final step is to, well, it's part of step 5, I guess, is to visualize Qs in an ROC space. And to do that, again, we plot the object, but now we include the argument what equals Qs. When you run this, you see a ROC curve, and this will show you how accurate each of the individual cues were in the data set. So here we see that there are 13 cues here, which correspond to the 13 in the data set, and the top 5 cues are highlighted with colored points. So in this case, the top cue, rank number 1, was tall, which is just exactly what we saw in the tree. It's the number 1 cue, so it's the first node in the tree, followed by CP and CA, and we can see those 3 are really bunched up here towards the top left relative to all the other cues. So this suggests that these really were the 3 best cues. But if we were interested in looking at potential other cues, then this suggests that old peak and slope were really the next best. But again, slope is actually quite similar in this case to these 2 cues. So this gives you a nice idea of, well, how valuable were the different cues in making the predictions. And that's about it. For additional details, you can consult the package guide. So again, you can do that with FFTrees.guide. And when you do that, you'll get some more information and links to different vignettes. You can also look at the help menu for FFTrees using basic just question mark FFTrees. And you can look at all the different inputs and descriptions of the different arguments. So thanks for watching.